Good morning, dear students. How are you all? Fine? Okay. So this is a video of class 10, and in this video we are going to discuss about the modern periodic table just after the Mendeleev's periodic classification of the elements in the periodic table. His periodic table was discarded because of some of the problem. His basis of classification was atomic masses. Previously what we have done, everyone's basis of classification was atomic masses, and you have the idea that this one was the disadvantage. We are not still found that the periodic table on our expectations, so that's why this modern periodic table is there, and this is also called as the long form of periodic table. Okay, now here you can see that was designed by Niels Bohr and the combined effort of Henry Moseley also. Okay, in this table, the elements are actually arranged in column vertically. Earlier you have also read vertically, that one was named in the Mendeleev's periodic classification, that one was considered to be as the group also. And here in this table, the elements are arranged in order of increasing atomic number. So you can see, dear student, as Henry Moseley, we have seen that one, that the basis of classification was atomic number, and you will find out lots of issues will resolve in this classification. Basis of classification I am changing, and atomic number we are actually accepting. The basis of classification should be, though every problem would resolve. Okay, now so here you can see in this table, the elements are arranged in order of increasing atomic numbers in rows. Okay, now in rows horizontally we are actually arranging, and that one would considered as a periods. Okay, now so here you can see modern periodic table is also based on electronic configuration, because we know that electronic configuration we can consider, we can derive from the atomic number. We cannot derive the electronic configuration from the atomic masses, so we can have to see that one, that electronic configuration actually we have derived from the atomic number, and it is actually a thing that we are talking about the modern periodic table. That one was based on electronic configuration. Yes, valency, group number, periods number, everything we can obtain from the electronic configuration. Just after writing the electronic configuration, we can say directly that this elements belongs from which periods, which group. Okay, now we will see later on. And then after, you can see in modern periodic table, the columns are called grouped. Okay, and the rows are called periods. So we have discussed about that one, but here I will actually want to give you some of the idea about that one. Here you can see this one should be the arrangement of the and distribution of the periodic table, just like this one. Here some of the element, that one is hydrogen, and here helium is there. Okay, na? And this side lithium, sodium, potassium, rubidium, cesium, francium. Okay, now everything is there. Okay, so only one group I am driving, helium, neon. Okay, now then after argon, krypton, xenon, radon is also there. So you can see that horizontally I am going, so this one is known as rows. Vertically I am going, this one is known as groups. Okay, now this one is known as vertically in the column, that one is known as groups. So till now what we have discussed, that we have understood. Now when I will go in the deep in this classification in this lecture, we will see that he actually discussed some of the name of the group also, and this one last. Okay, now this one at the last, it is known as a zero group, as this is not having any of the valency. This is also known as noble gases also, and this is alkali metal, as this is very reactive one. It is actually gives us the strong basis, so this is alkali metal. Then after second group would be there, that one is alkaline earth metal. So we will see here, you can see that the table is there. Then after groups in modern periodic table, there were total 18 groups were there. Total 18 groups were there. Some are given special names on the basis of its properties. Properties means what? Which type of the compound it is forming, which type of the reactivity it is having, which type of the bases it is forming, which type of the acid it is forming. On that basis, on the basis of its reactivity, on the basis of its properties, its special name is there, and that we will discuss with you all. That the first group, here I have told you the first group, that one when react with water, suppose lithium is there, okay na, lithium when react with water, if suppose Na is there, if suppose potassium is there, all that when reacts with water it will form a strong basis, and that one is known as soluble basis, and that one is a strong basis. That means alkali they are forming. Lithium, sodium, potassium, these are also, we can say, the strong reactive elements, and they will form the strong basis. That one is the alkali they are forming. So this one you can say that the first group elements are called alkali metal. And why this is alkali metal? Because they have a strong tendency to react with water, and after the reaction they will form the strong bases and the alkalis. So you have understood the first group is known as the alkalis. Okay, a strong basis formation. The second group elements are called alkaline earth metal. Second groups are elements are called alkaline earth metal. Alkaline earth metal means that is also basic in nature. If it will react with the water, okay na, so alkalinity will increase. Second group elements are also called the alkaline earth metal, as it is obtained from the earth. Okay, the 16th group elements are called chalcogens. Chalcogens means salt, ore formers. Ore formers means what? Chalcogens. 16th group, 16th group na, you can see 16th group is elements are also called as chalcogens. So what does it means? You can see the 16 group elements, oxygen, okay na, 16th group elements, so oxygen, sulfur, selenium, tellurium, polonium. So this one 16 group. So oxygen, you know, is the very reactive one. If there is so a very much reactive element like sodium, like potassium, like lithium, it will react to form Na2 quickly. So this one has formed one of the oxide ore. If I am talking about sulfur, then if it will combine with Zn, zinc sulfide, it will form. If it will combine with mercury, it will form HZS, very reactive one, ore former. So that's why this one is chalcogen. The name is special, is name is derived from its properties, okay na, ore former. Then after the 17th group elements are called halogens. Halogens means what? Halogens means chlorine, bromine, iodine, okay na. That all these negative means anionic part accepting electron, gaining electron, and they actually form a salt, okay na. If I am talking about here Na, and if halogen, if I am talking about chlorine, bromine, iodine, what will you get after the combination of Na, NaCl, NaBr, NaI, okay na? So this one without the Cl it is impossible to form a salt. This one is a common salt, everyone you know. So that halogen family is known as the salt, sea salt producing, okay na. So here in brief you can see, you can read that one by one: alkali metal, then after alkaline metal, then after chalcogens, then after sea salt former, okay na. Then after you can see the rest of the groups are named by using first element. 3 or 4 especially names you have seen. First one alkali, second one alkaline, 16th chalcogens, 17th halogen, 18th also I am giving you, here it is written, okay, here it is written 18th elements, 18th groups are also known as zero group or noble gases, because its valency is 0. Now you can see here, dear student, that some of the rest of the group are named by using first element. If nitrogen is there and nitrogen is not having any the special property, then you can say it is belongs from the nitrogen family, okay na? It is belonging from the nitrogen family. Nitrogen, phosphorus, strontium, okay, this one, these all are the elements, these all are the element of the 15th group, nitrogen, phosphorus, arsenic, strontium, then bismuth. So this one you have seen that it is belonging from that nitrogen family, the first element. From its name only you have to tell nitrogen family. 13th group is boron, starting from boron, aluminium, gallium, indium, titanium. So that belongs from the 13th family. Okay, if you have not a special properties of that one, then you can call it from that family only. The elements of group 3 to group 12 are called transition elements. Transition element because metals are on the left hand side, non-metals are on the right hand side, and in between non-reactive means we can say metals are reactive, non-metals are accepting the electron, they have their work. But transitions is creating some of the gaps, some of the zones between the reactivity and between the less reactive and high reactive. It is creating a zone, gap zone. Okay na? So that gap is known as transition, or in one meaning transition means gap. Okay, so that all from this video. Thank you all of you.